Hello everyone, and welcome back to Weather with Ryan. It's been a while since the last installment, but today we're back and we'll be discussing weather balloons. The inspiration for this video came from a question that is frequently asked on weather pages and blogs across the internet, which was something like, are weather balloons still used? Unlike past videos where I ramble on about moderately related things before answering the question, today I'll start with the answer. Yes! We absolutely still use weather balloons, as they are not only crucial to our understanding of the atmosphere, but they are also unparalleled by any other observation system in their ability to sample the vertical profiles of our atmosphere. Using data from these balloons, meteorologists can predict different atmospheric phenomena ranging from towering thunderstorms to glistening white snow. And with that, let's dive into the fascinating world of weather balloons. Across the United States and the world, weather balloons are launched twice a day at 12Z and 0Z, or 7 a.m. and 7 p.m. Central Daylight Time. However, sometimes balloons will be launched at other times if inclement weather is expected. As a side note, I often interchange between calling it Z time, short for Zulu time, and UTC, short for Coordinated Universal Time. They're both equivalent, and they're often used interchangeably. But anyway, back to balloons. Balloon launch sites in the US are primarily operated by the National Weather Service, which are the locations in blue on the map in the background. But there are other balloon launches in the US, and they're by the Global Climate Observing System, and they're shown in red on the map, which are sponsored by the World Meteorological Organization, which is a division of the United Nations. One interesting point of interest is that not every weather forecast office launches weather balloons. For example, the Chicago Weather Forecast Office does not launch a balloon, but Lincoln, Illinois, or ILX on the map, does. There are also balloon launches in Alaska, Hawaii, and other Pacific islands encompassed in the US and Global Climate Observing System network. For those offices that do launch a balloon, there will be an upper air building where the balloon will be inflated and prepared for flight that look just like this building at Lincoln, Illinois does. The small dome on the top of the building contains the antenna that will be used to track the weather balloon once it's released. And another side note, that giant golf ball behind the building is a radar, which is not associated with the balloon launch system in any way. Courtesy of my friend Carter Humphreys at the Weather Forecast Office in Flagstaff, Arizona, we have an inside view of one of these buildings and the process of launching a weather balloon. The first step is to inflate the balloon. The balloon is attached to the nozzle on the left side of the screen and is filled with hydrogen. Once filled, these balloons are quite large. The exact size depends on how much gas is used, which depends on the weather conditions. With the balloon inflated, what's called the train is attached. The train consists of roughly 100 feet of twine, a parachute, and the instrument. The parachute is included so that the instrument slowly descends back to the surface once the balloon pops, which can be as high as 100,000 feet. At the end of the train is the instrument, which is called a radiosonde. A radiosonde measures pressure, temperature, and relative humidity. Using GPS, the radiosonde also measures wind speed and direction. Because of this, they're actually what we call a raw wind sonde, but meteorologists simply call them a radiosonde. Once preparations have been completed, the balloon is launched into the atmosphere and begins sending back data. Eventually, the balloon will pop and it will fall back to the surface. Because of this, it is possible that you may encounter a radiosonde and weather balloon in your adventures. If found, there are instructions provided on the device of how to dispose of it. Now that the balloon has been launched and the radiosonde is collecting data, we need to visualize the data so that it can be used by meteorologists around the world. Two common charts that are produced from this data are upper air charts and what we call a sounding. Upper air charts display the wind speed, direction, temperature, dew point depression at height at a given pressure level. The map shown here is at 500 millibars, or about 6 kilometers or 19,500 feet, but more on this in a future video. The other key chart that is made from radiosonde data is the sounding, which shows how the temperature and dew point of the atmosphere change with height. It also shows how the wind changes with height. Most commonly, these are displayed as a skew T log P, which is what's being shown. Although these look incredibly complicated, they are crucially important to weather forecasting. These soundings are used when taking in data for weather models and are used by meteorologists when making your daily weather forecast, as every sounding tells a story and gives us a snapshot of our atmosphere. Soundings are especially useful for forecasting thunderstorms, microbursts, winter weather, and many other important aspects of meteorology and the weather that goes on in our everyday lives. Now, let's look at an example. This sounding was taken at 12Z on August 10th, 2022 in Flagstaff, Arizona, and would be indicative of thunderstorms. I won't cover the details of why this is the case in this video, but you can trust me. I'm a meteorologist. Switching to the high resolution rapid refresh model, also known as the HRRR, which would have used the data from this balloon launch and others around the country to create a forecast, we can see that it shows thunderstorms forming throughout Arizona throughout the afternoon and evening. Of course, this is just a model and not the true weather. So let's look at the actual radar loop from that afternoon to see if our predictions are correct. This radar loop spans 8 hours beginning around 5 a.m. local time, which corresponds to Mountain Standard Time if we're looking in Arizona, and ending around 1 p.m. Mountain Standard Time. If you're still wondering about Z time that we talked about earlier, the radar loop begins at roughly 12Z when our sounding was launched and ends at about 20Z. As the morning hours wane and the afternoon hours begin, we see that thunderstorms begin to sprout throughout northern Arizona, beginning west of Flagstaff and then becoming more widespread as the afternoon progresses, which is consistent with the HRRR model as well as what we observed by looking at the sounding. Although there are other observation systems available to measure the vertical properties of our atmosphere, such as sounders on satellites in space, none are as effective as the radiosonde attached to a weather balloon, and because of that, the National Weather Service has been using balloon-based radiosondes since the late 1930s. If you're interested in learning more about weather balloons and radiosondes, the National Weather Service website has many resources available to you to check out, and I've linked them in the video description. And as always, if you enjoyed this video or learned something from it, consider liking and subscribing. And until next time, keep looking at the sky.